Consumer units installed in domestic dwellings should now be of a non-combustible material or housed within a non-combustible enclosure. Industry took the route of going down the metallic non-combustible style consumer units for Amendment 3 17th edition distribution boards, moving away from the previous plastic consumer units. So they didn't go down the route of installing them in a non-combustible housing, so having another box around the consumer's unit or distribution board, whichever you want to call it. We went down the route of installing metallic distribution boards. The thinking was that the distribution board could draw anything up to 100 amps. So think of the cutout fuse installed in a domestic dwelling being a maximum of 100 amps, it could be 80 amps or 60 amps, meaning the consumer units itself can be drawing anything up to 100 amps, therefore drawing the most amount of current in any electrical enclosure domestically. So this would be the largest centre to draw current from. Then we go down the route, and we looked at a previous video, the requirement to use torque screwdrivers to set conductors at manufacturer's tightness. And we can see here how that's failed on the bottom of a circuit breaker and the top of a main double pole switch, where potentially the connection has been either over tight or under tight, causing to generate massive heat. That massive heat causing potentially a fire. As we can see in the plastic consumer unit, the consumer unit has instantly almost melted and the fire is spread into the building, where to overcome that, we're installing metal clad consumer units holding or housing the fire for longer periods of time inside the metallic enclosure. Because of the issue of installing PVC, PVC twin and CPC cables into a metallic enclosure and therefore having the potential for a soft wiring system to rub against the harsh metalwork, we can see that also where the wiring system is on the surface, that glands have been introduced to support the conductors and also the tails. So we've got the tails now supported. Traditionally, the tails would just be positioned into a consumer unit with no additional support, meaning again that they could potentially be drawing 100 amps and potentially be moving or wiggling about into their connections on the top, which again over a period of time can cause them to work loose. A loose connection can cause a fire. We're back down the route of the distribution board causing a fire in the installation, which is unacceptable. So we've got now the fact that these glands can hold on to the cables, in this case the tails, preventing additional movement, okay, and cable glands to hold our PVC wiring. Still, traditionally, the wiring system would enter the back of the enclosure, the plates at the back here would be removed, the wiring system would be buried within the fabric of the building, and the conductors come into the back of the consumer unit, removing the need for surface mounted glands. However, in some installations, a surface mounted gland would be required. The other benefit of the glands is that, allegedly, according to manufacturers, they help maintain the fire rating of the metallic electrical enclosure. They also reinstate the IP rating. Remembering, during our studies, we must remember the IP rating at the top of any electrical surface must be IP4X, so objects exceeding 1 millimetre cannot enter the top of an electrical enclosure. We're looking at dust in that respect. And the rest of the electrical enclosure, whether it be sides, front with a cover on, or bottom, must have an IP rating of IP2X. In real terms, we're looking at not being able to stick our index finger into the remainder of the electrical enclosure. We'll develop that as we go through our levels and actually clarify that as IPXXB. For at the minute, IP4X on the top surface and IP2X on sides and front and bottom surfaces, in order to maintain the electrical integrity of any electrical enclosure, not just consumer units, lights, switch, sockets, etc. Some of the thinking behind the moving away from a traditional plastic consumer unit during Amendment 3 of the 17th edition wiring regulations and coming onto a domestic consumer unit now that's made of a non-combustible material, so therefore we've gone for the metal clad or metal consumer units. We've kept the IP ratings correct as always, and we've supported cables again to further reduce the chances of an electrical fire through vibration of conductors, etc. We've moved towards a torque screwdriver in a previous video, so manufacturers' terminations are returned to the correct tightness, not over tight or under tight, and again in order to reduce the risk of a fire within such a heavy load centre, being the consumer unit anything up to 100 amps. Other key points that we can point out while we're doing this, and we're doing other presentations as well, is some of the features incorporated within the consumer's unit or distribution board, whichever you want to call it. The main switch, double pole or linked main switch, okay, just there, isolates both line and neutral, and we call them together live conductors, so therefore they're simultaneously isolated. So when you operate the switch, both line and neutral are isolated, both live conductors in the consumer unit, so the consumer therefore is turned off. We talked about secure and isolation in previous videos as well. We have overcurrent protection. in the form of a circuit breaker. So we've got what you might be calling the trip switches in your early days, but circuit breaker offering overcurrent protection. We've got additional protection, in this case offered in a couple of different ways. RCCBs protecting several circuits for earth faults, and individual here RCBO offering RCD protection or earth fault protection for an individual circuit rather than with the RCBO for several circuits of protections. Those can be used for additional protection because they are rated at 30 milliamps or less. In this case, both the RCBO and the RCCB are rated at 30 milliamps, and we'll look at additional protection as well in a later presentation. So that's some of the thinking behind the Amendment 3 of the 17th edition wiring regulations, and why now all consumer units installed in brand new domestic dwellings, or where a rewire has occurred in a domestic dwelling, or where the consumer unit is changed in a domestic dwelling, that we're now installing a consumer unit of a non-combustible material. So in other words, we're installing a metallic consumer unit.